Hi everyone, I'm Abishek Kashyap. Thank you for joining. Give me a second, I'll share my screen. So I'm Abishek Kashyap. I'm the lead for product management for open source data analytics on Google Cloud, including Spark. And I will give you a brief overview of how Google Cloud customers are building a scalable and secure data platform. And hopefully that could give you some ideas for what you could do to get there. As you all might have seen, there are projections that data is growing at a really high rate. It's expected to be about 5x, and this data point is old. Guess is that because of the recent unfortunate event with the pandemic, this is likely growing even faster because a lot of acceleration has happened as more and more customers have come online. And we are seeing businesses driving their growth online as well. What this has resulted in is a much higher focus on analytics and AI. So when uh, the board of directors group did a survey among uh, board of directors. What they found was that among all the new technologies, they felt analytics and AI, which should be the top focus. And this was not the case a few years ago when the projection for data growth was made. So, what are some of the customers doing to get there? Before talking about that, let's look at what a data lifecycle looks like in this world. So, data is generated by applications. Now, if we are an online only company, the application is mostly going to be your website and mobile apps. But if you talk to any larger enterprise, a key application here becomes the ERP system, which is where all your transactions are stored. So, your applications generate data that goes into the databases. From databases, you take some of the data that you use for your data analytics platform, you do analytics, you generate KPIs, you generate training data for your machine learning models, you train them, you then use their predictions to optimize your applications and customer experience through those. And then that generates more data and goes into the databases. So the life cycle is cyclic. You need data to be fresh. A lot of different users interact with it. Your software engineers for the applications, to DBAs, to data engineers and data analysts and data scientists, and not to mention ML engineers. Now, how do you create a platform that makes it easy to build this data lifecycle? Let's look at this data lifecycle in action. So let's say you're looking for a tankless water heater. You go to a retail website and you want it today, so it will show you how many are in stock at a store near you. Now, how many are in stock is coming from your databases, so it better be fresh. You don't want to get somewhere and find out that this data was 1 week old. So the data needs to be fresh. Your application shows availability. The other things you see on the web page are when you searched for tankless water heater, there were 266 options. This was the bestseller, and this was the aggregate customer rating. Now, all these do not come from raw data. These require capabilities that are core part of your analytics data platform. So again, most likely, uh, either overnight or a few hours ago, uh, this aggregation would have happened in your analytics data platform. Your search index would have been updated, and all these results would have shown up from your analytics data platform. Now, the third thing you see is when you go further down the page, you see other accessories you need to buy with it. Now, we are not relying on the manufacturer to do this, because this needs inventory and your catalog of this website. So, this is a market basket analysis that happens in your machine learning modeling. And that feeds into your applications, and your user gets an amazing experience where they know where to go, what to get, what else to get, and that they're buying the best selling product. Now, to make something like this happen requires a lot of work to build a data platform that scales, is secure, has real time data, and serves all these users that have made this user experience possible. Let's see what this means at the next level. If someone is on prem today, we show what they might be doing in this row at the bottom. Now, building a data platform that I showed requires to move from very expensive traditional storage to inexpensive managed cloud storage, because you're likely going to get to petabytes, hundreds of petabytes of data in a scenario like that fairly soon. And you just cannot afford it with the traditional storage. You need to get to real time data processing. If you are to uh, give customer real time recommendations, it cannot be based on slow manual batch ETL jobs. Some of those workflows have to be real time. Now, to tie all these systems together, all the way from applications to databases to analytics to machine learning to BI, you have to have an open and flexible universal semantic system. You cannot have uh, systems which do not talk to each other, which do not share metadata, and then expect that you'll be able to build something that's scalable. So this becomes a key, because you are re-architecting your whole data system to work together. Uh, a lot of times you'll find that the data and the action is not just dependent on your company. You need to work with partners, you need to purchase data, you need to provide them with data, and for that you need a governed and scalable data sharing system. I showed machine learning recommendations on the last page. To make that happen, you really need to build in machine learning into your pipelines, into your processes, into your analytics platform. If you consider your data science team as a separate team that does special projects and need to download data into their own cluster of VMs, it's not going to work out. So, machine learning has to become an integral part of your data platform. And finally, you have to present this in an integrated manner to all your users, to platforms that they use, and through user interfaces they are familiar with. So your data scientist might want to use a notebook but have access to uh, the data that they need with the right controls and use it for training. Your data analyst should be able to go to a BI tool and do the same, and you can extend it to other personas. So you have to really go from a very different state today to a modern architecture to achieve the user experience, both external user and your internal users that they really need to make this journey. Now, at Google, we have 10 products with more than a billion users. And as a product manager, I can tell you it's really easy for me to go in and do analysis on revenue usage numbers that I need to use for my products to make the product decisions I need to make. And we have done this at scale for many, many different products. And I'll just show you some customer examples who are able to do the same with Google Cloud as we bring this same technology through Google Cloud to them. Since we mentioned scalable as the first word for data platform, let me start with an example of a social media company that demonstrates the scale you can achieve. And as you go more and more online, you'll find that you'll get to the same place. Now, the social media company has to process more than 1 trillion messages daily. They have more than 300 petabytes of data stored in uh, Google Cloud already, most of it in our data warehouse, which is BigQuery. And they're already using more than 500,000 compute cores. So that's the scale that they need to upgrade their business. And they have the data platform with Google Cloud to be able to do that. Now, scale is not the only constraint here. If you look at the example I showed earlier, that was a retailer that had an online store and physical locations. Now, in that case, if you think about availability of an item in a store, that has a really large impact on both revenue and user experience. So a large project they did was, let's predict inventory needs at the SKU level at each store. So we can reduce shelf out, and we can also delight our customers by having it available when they need to. So this has a lot of operational complexity. You need very fresh data all the way from your store to what shows online, what goes to your machine learning model, and then finally to your supply chain software in your ERP system. So you can actually say, in this store, I need these many items for this particular SKU on this date. Now, they have made that happen, and it's running fairly well, saving them millions in lost sales. The third complexity with scale I wanted to show was regulatory. So we have a really large FinServ client that needs to run liquidity analysis. So they need to calculate the liquidity position of their bank in each country they serve. And they work on 10 petabytes of data, but to do this, the calculation was taking 10 hours for each of them. And that was really stopping them from doing anything else. They have moved to do this on our data warehouse, and they now do this in 30 minutes per country. So the productivity that they get now allows them to focus on things which actually affect their business. And they're able to do this under all the regulatory and compliance constraints that a large bank has, being in tens of different countries. Now, what I mentioned in these examples and slides earlier were some of the tenets of what we believe a modern data platform is. And those are scalability, security, and governance, because without that, it's uh, just getting to a point where the business may shut down altogether. And third is end to end integration to be able to serve all your internal users who are building your products uh, very well. Let's look at scalability. Scalability has two key elements. The reason this social media company got to the scale they did was because of two things. One was separation of storage and compute, and second is being serverless. So when you think about separation of storage and compute, what you want to do is you want to store this 300 petabyte of data uh, that is segregated from what compute you might run on it. So with Google Cloud, we have a low cost object store, and we have a highly optimized analytical store for data warehousing workloads. You can put your data in either of the two based on what the data is, and then you can run your processing and analytical engine of choice that will scale independently of the storage. You can run Spark in Dataproc, Apache Beam in Dataflow for streaming, BigQuery SQL, build your ETL pipelines with Data Fusion, run your machine learning models through Cloud AI platform without tying any of that to the underlying data. So you can scale the two of them separately. And this is the fundamental tenet of building a scalable data platform. Without doing this, you'll always be tied between compute and storage, and that will not allow you to scale. The second element of scalability is being serverless. So if you talk to any DBA or data engineer who's working on a self-managed Hadoop cluster or a data warehouse on-prem, they'll tell you how much time they spend in thinking about virtual machines, resource provisioning, fine-tuning, putting in purchase orders because they'll need to scale 6 months from now, etc., etc. All that needs to go away. So you need to provide a fully serverless, self-managed service where if a user wants to use data warehouse, all they think about is SQL queries. If they want to use Spark, all they think about is code. They want to use streaming, all they think about is again code and some of the requirements for streaming. We don't want users to spend all their time on infrastructure provisioning and monitoring. And if you think about your data lifecycle from collection of data to analysis, we have serverless products for each of those phases. With PubSub, we have a serverless auto-scaling messaging queue. For processing of data, if you have users who use Spark, we have Dataproc that provides the ability to run serverless Spark. We have Dataflow that allows users to run serverless Beam. And these are both based on open source. And third, for analysis, we have BigQuery, which was the first serverless data warehouse. And that's essentially the one that set the stage of how to be serverless. To again repeat the scale that people get with BigQuery, we have a customer with 300 petabytes of data. We have multiple customers who have run queries on 100 trillion rows on BigQuery. Now, this is something you cannot do if the product is not serverless. You just cannot buy that many machines for your own data center and co-locate it with data. So it has to be serverless. Storage and compute have to be separated. And finally, you may have a lot of users and applications. There are customers who have run 10,000 concurrent queries on BigQuery. Now, BigQuery is primarily focused on SQL-based analytics. SQL brings very different security constraints than programming languages like Python, because Python, you cannot have a multi-tenant secure architecture as you can have with SQL. So for distributed Python, we recently announced and launched serverless Spark. So you can write Python code from an IDE, from one of the GCP products, from a pipeline tool. You don't worry about infrastructure. It will auto scale, get the job done, and work with both storage types that we have. And this works with virtual private cloud environments with encryption keys, all the security features that customers need. So with this, you have the ability to both do serverless SQL as well as serverless Spark. And for streaming, we have had a serverless option with Apache Beam with Dataflow. Now let's move over to security and governance, because if you are going to have this scale of data, a lot of which is PII, users spread across business units and functions, and data spread out between a variety of sources. This is absolutely critical. If you end up filing tickets for every access request and someone manually doing this, and manually doing auditing, it's going to become very, very hard to scale. So for security and governance, we have a product called Dataplex. It essentially allows you to take a logical view of all your data spread across data warehouses, data lakes, data marts, and build a centralized governed set of data lakes whose life cycle you can manage. To double click on this, what that means is, let's say you have data stored in a variety of places, it's structured, semi-structured, streaming, and you have analytics happening through BigQuery SQL or through Spark or Dataflow. This provides a layer in the middle that allows you to set up automatic data discovery, harvesting its metadata, doing things like read a file from object store, write it as a table in BigQuery, write its metadata where it's going to go, and ensure data quality. So do things like alerting if a file was missing somewhere. So you can do this full data lifecycle management on data stored in different formats across storage and make it available through different analytics platforms. And you can, this is where then you can apply unified security and governance. So users, service accounts coming through a particular analytics engine would have, say, row level access control on data stored in BigQuery, and it could have some other cutoff tackles on a bucket and file within Google Cloud Storage. So what you would do is you would store your data where your applications need them, split your applications from the data, and have Dataplex manage security governance and lifecycle management for these data lakes. The third part I mentioned was about the ability to provide end-to-end integration and provide them to the users within your company through the tools they use. The most common way customers do this with Google Cloud is through BigQuery. So with BigQuery, you can have data stored in BigQuery storage or someplace else because it supports external tables. You can check it for, say, PII with something we call data loss prevention API. Uh, it will work with data catalog for metadata. You can stream data in through PubSub, Kafka, uh, one-click integrations with many SaaS applications. And then all this is available for analysis in a secure way through AI platform, Dataproc Spark, Dataflow for streaming. Uh, all BI platforms work with it. And we also provide a spreadsheet and natural language interface for citizen data scientists to work with BigQuery data. So that's a platform we see being used for analytics consolidation among our customers a lot. To make it clear for one of these examples, if you have data in BigQuery, you can now go to BigQuery and you can write your PySpark code and execute it, which executes in a serverless manner on BigQuery data, just like it does for serverless SQL. So this is an example of an integration that you can provide to your end users of working through the same platform, but doing the work through languages and interfaces they like. I did want to show one slide on how we service data scientists. So data scientists like to work through notebooks, but it's not just machine learning. If you think of a data scientist journey, they want notebooks that they don't have to manage. They want to analyze data that could be in BigQuery storage, it could be in an object store. They may want to run SQL on it, they may want to use Spark, they may want to use Python with TensorFlow. So this integrates. uh, Vertex AI Workbench has Jupyter notebooks that integrate with BigQuery, with Dataproc for Spark, for data analysis, data exploration. Then these can be, uh, the features you create can be used for training. So Vertex AI has AutoML, BigQuery ML. It has deep TensorFlow, which is a Google project. TensorFlow integration, and once you train, you get things like model registry, you get uh, full pipeline solutions, and you can just schedule these notebooks as those pipelines. So again, from a data science perspective, you just go to this notebook and all the underlying machine learning and data analytics capabilities are provided through this notebook. You don't have to go to 10 places. You don't have to go browse data somewhere else and then go work here. And that's what an end-to-end platform means. We are at time, so I wanted to end with this slide that shows the products we have for each stage of a data pipeline. You might think that these are too many products, but if you do go to any customer that's even medium size, what you'll find is different groups within the customer have different needs. They work through different tools. You might find one group that loves Spark. You might find another group that needs to use Beam. A third group wants to use SQL. So to really help this customer build an end-to-end integrated data platform, we provide this fully integrated, very sophisticated set of products that has an interface for each of the users who needs to use this for applications that you build. With that, I'll end this presentation. Thank you. Thank you for your time. If there are any questions, please type them in chat. So one question I have is from Osmani. Excellent work. This allows us to focus on the data teams that enable you to build a secure and scalable data platform. Thank you, Osmani. We look forward to working with you if you decide to try us out. Great. If no other questions, I'll end this broadcast and enjoy the rest of the conference. Thank you.